Okay, so here's my few random questions. Okay, so I gave you this equation. It's nowhere. Don't look for it. It's nowhere. It's just on the board. It's nowhere in your booklet.
So you want us to write it down?
Nope. Okay, here's an equation. The profit, or the price, equals 25,000 times 0.8 to the y, where P equals the price and Y equals the years. What does the $25,000 represent? So it's modeling the price of a car. So what is $25,000 in this situation? The price at the start, yeah. So the price at the very start, yeah. So what does the 25,000 mean? Starting price of car. Okay, what does the 0.8 represent in this scenario?
The rate of decline.
The rate, and we said decline, it's a decreasing. So the car price is going down. Do you understand the word depreciate? Have you ever heard that word in real life? Depreciate, something depreciates. Do you know that your car depreciates? Like you buy a car and then you go to sell it, it's going to be less money, right? That's a depreciate. Okay. What is the actual rate of depreciation?
20%.
It's 20% depreciated. Okay. So 0.8 is 80% of its value. So it's gone down by 20%. Okay, does that make sense to us? 0.8, okay, is 80%. Your car is 80% of its value. It has gone down by 20% of its value. Okay, without graphing, what is the price of the car in 4 years? So don't graph, but you can get your calculator out. In 4 years, what is the price of my car in 4 years? What am I doing? Don't graph it. I don't want you to graph it. What is my price of my car in 4 years? So what would you do? Just on a regular calculator, not graphing.
Times it by 0.8.
So this times 0.8.
Times 4.
Now, that's the price after 1 year. Right? So then I go times 0.8. That's the price after 2 years. 3rd year. 4th year. So after 4 years, when you sell your car, now that's the price of it. Okay? Or faster would have been to the exponent 4. But that's what's happening. Okay, I wanted to do it a bunch of times so that you could see that each year, an 80% of its value, then 80% of that value, then 80% of that value. Okay? So now this is a house. So there's my equation for a house. So what does 230,000 represent? The starting price of our house. What our house cost today. Starting price. Then we have a 1.03 inside the base. That's the base, right? So what does that represent? The rate, and it's a growth rate. So if I ever asked you what percent was your house appreciating? Appreciating. The word appreciate, have you ever heard that one before? You can You either appreciate or depreciate in life. So appreciate so does anybody know the price? Every year it increases the value by what? 3%. Okay? 3% appreciation rate. Okay? Because that's how much I am over 100%. Because 1.03 is 103%. So I'm 3% over. So then, what is the price of your house after 5 years? Can you tell me that just without graphing it again? How much is your house worth if you go to sell it 5 years later? Are you getting? 266,633. Okay, so that's what I got. And this is a real life thing. This is exactly how you calculate, because houses usually appreciate, cars usually depreciate. Okay, and then my last question here. The number of bacteria in an experiment tripled every hour. After 5 hours, this was the population of the bacteria. What was the number of bacteria at the beginning of the experiment? Okay, can you draw me a T chart, please? Okay, so basically I'm going to say the hour and the number of bacteria. Okay, I'm going to put hour 0 because that's a start. At hour 0, hour 1, 2, 3, 4, 5. This is what happened, and what I'm trying to figure out is this. At the start, at the 0 hour mark, what's the population of the bacteria? That's what we're trying to figure out. So we know it's tripling every hour. So whatever we were, it tripled. So how do we go back to what we originated with? What do you want to do? Divide by 3, divide by 3, divide by 3, divide by 3. Okay, or you could divide by 3 to the 1, 2, 3, 4, 5th exponent. Okay, so that works, or you could have divided by 3 to the exponent 5, because I'm doing it 1, 2, 3, 4, 5 times, right? Okay, so that's a little bit of side questions you get besides just graphing the function, is just understanding, again, what is going on when you calculate math with exponents. Okay, so now we're going to jump to our notes and finish off exponential stuff, and then we're done exponential. Okay, so here's a chart. So we're going to go back to our stat edit stuff. It doesn't tell me anything like X is the number of years since. It doesn't tell me that, right? I don't see it anywhere, so we just type in what we see, I guess. I don't know if I like this, but... So, I typed it all in. How do you see it again? You go to y equals and activate the plot to see points. Get everything else out. Zoom 9 is going to help my window for me. So there it is. So draw a scatter plot is the first question. So this is me drawing a scatter plot, kind of just showing you what does my screen look like. And I have to put labels on these. So variable what on the bottom, variable what on the y-axis. So we would talk year and population. So the population, is it growing or declining, the population? It's growing. Okay, so find an equation is number 2. So we do stat calculate. Now this is a new option. We haven't done it. So we are going to go to number 0 there. You see it? It says EXP. That's exponential. Okay? Okay, ooh, this is kind of awkward. What does this mean in math when it's like 9 e to the negative 18? Do you know what that means? It's really the number... That's what number that is.
Wait, you know how many zeros?
Well, it had 17 zeros because it went to 18 decimal places. So let's write that in as it shows me on my screen, because I'm not going to write that. So that's what I'm going to do. So whenever you see the e to like something negative, that's what's your numbers. Did somebody match me? Did you match our data?
You already completed? No, sorry.
Okay, so let's graph the equation. So we're going to go y equals copy and paste. Copy and paste feature is vars, stats, equation. It's in there. If you want, you can graph it and it would show you how well it fits your data. Okay, but basically I don't want the points anymore. I just want the graph. So points out, deactivate the plot. Okay, so the actual question says, assuming the population is going to continue to grow like this, what is the population in 2011? So, did I give you an X or a Y value? That's always what you ask yourself. I gave you an X, and X is actually 2011. So be careful if we had used let X be the years since, right? You would have had to adjust your X value, right? So then what do? Just trace. Trace 2011, enter. And then it gave me this, quit, error. Why? What would be the problem? It'll be a window issue. So going back to my window, looking at my years, this went to 1981, so 2020. I got to go something bigger than 2011. And then we'll try again. So trace 2011. And then this time it should work. So 54.15 million people. Okay, the last question here. Sonia was doing an experiment about the cooling of water. So when you have water and you've boiled it, right, eventually it will just cool down. And this was her experiment of hot water in 3 cups. She recorded the temperature, and here's her data. We obviously can't use 3 digits. So what we're going to do is we're going to find the average. Okay? Let's split up. Caius's row, can you get the average? Jaden's row, average. Lane's row, average. Artemis's row, average. And I'll do the last 2. We're going to go 2 decimal places, right? Anybody for the 0 time? 77.6. Anybody have a 5-minute marker? 10 minutes? 60.33. And the 20-minute? 0.33? Okay. Now, here we go. Let's go L1, L2. L1, L2. That's what we're going to do now. Okay, it's in there, so we're going to do all the same steps. Y equals, well, that's out. Just activate your plot. Get everything else erased. Activate plot, zoom 9. Okay, it's kind of making a shape like that. So on my scatter plot, I should do time and temp labels, because those are my variables, on which axis. So there's a scatter plot. That's all I look for with scatter plots. Did you kind of show me what your calculator has as a shape and labels? Okay, now we got to get an equation. So I need you to do stat calc. 0. Stat calc exponent regression. Enter. Okay, so what does this also tell me? Do you remember? Why is this 0.97? What does this tell me about the curve? It's decreasing, right? Did you look at our last one? Our population was growing, and when what was our base? Over 1, right? Over 100%. Okay, graph it. Y equals vars, stats, copy and paste it. We're getting better at these steps because now you don't get your cheat sheet because you're supposed to be professional and by the second unit of this, right? Once I have the equation, I also don't need the coordinates in there, those points. Okay, so the water is cooling. What if I asked you the temperature of the water at the start of the experiment? What would you do? Trace 0. 78.68. Where did that come from? 78.68 was the starting temperature of the water, right? Estimate the temperature of the water 15 minutes after the experiment began. 15. Are we talking X or are we talking a Y? X, 15 minutes. Are we supposed to be in minutes or do we need to think about anything changing? We're good, right? Minutes, we were in minutes. On your test, all that time stuff was weird. If I gave you 15 minutes, but this was in hours, right, you'd have to think about how to change that number. So we should be able to do trace 15, enter. And I was getting 51.02. Estimate when the water reached 30 degrees. This time I gave you 30 degrees, so I would have given you a Y. So what do you always do if I give you Y's? Do a Y2. So Y2 is 30. So when did this water, boom, hit that 30 line? That's what you want to know, right? So we're calculating the intersection. And then I was getting 33.39 minutes.